Today we have to discuss integral equation problem. So first of all we have to discuss what do you mean by a integral equation. Definition: integral equation is an equation in which appear the unknown function under the integral. That is nothing but, so here alpha x into y of x equal to capital F of x plus lambda into integral a to b k of x comma t into y of t dt, where alpha, f and k are functions and lambda, a, b are constants is known as a integral equation, especially Fedorov integral equation. So a and b are constant, then the equation is called the Fedorov integral equation. And also, so y of x is a known one and y of t is a unknown function. Here y of t is a unknown function. Then we have to categorize into first kind and second kind, homogeneous and non-homogeneous. So first kind is nothing but alpha of x equal to 0. So from equation 1, put alpha of x equal to 0, a linear integral equation of the form capital F, that is nothing but left hand side equal to 0, capital F of x plus lambda into integral a to b k of x comma t into y of d dt equal to 0 is known as a Fedorov integral equation of the first kind. So what is the difference between first kind and second kind? So second kind is nothing but, so f of that is nothing but alpha of x equal to 1 in equation 1, then the equation is called the Fedorov integral equation of second kind. That is nothing but y of x equal to capital F of x plus lambda into integral a to b k of x comma t into y of d dt is known as a Fedorov integral equation of the second kind. So that is the difference between alpha of x equal to 0 is called the Fedorov integral equation of the first kind. Alpha of x equal to 1 is called the Fedorov integral equation of the second kind. Then homogeneous and non-homogeneous. So homogeneous is nothing but capital F of, in equation 1, alpha of x into y of x equal to f of x plus lambda into integral a to b k of x comma t into y of d dt, and f of x equal to 0, then the equation is called the homogeneous equation. That is nothing but a linear integral equation of the form. So first kind is nothing but alpha of x equal to 0, second kind is nothing but alpha of x equal to 1, and f of x equal to 0, then the equation is called the homogeneous equation, and also called the alpha of x equal to lambda into integral a to b k of x comma t is nothing but kernel. So k of x comma t is known as kernel of x, k of x comma t is known as a kernel, and y of t is a unknown function, is a linear integral equation of the form y of x equal to lambda into integral a to b k of x comma t into y of d dt is known as a homogeneous Fedorov integral equation of the second kind. So what is mean by a first kind? Alpha of x equal to 0 and f of x equal to 0, then the equation is called the Fedorov integral equation of the first kind. So that is the difference between first kind and second kind. Then first kind. So a linear integral equation of the form. So in equation 1, alpha of x equal to 0 and f of x equal to 0, that is nothing but a Fedorov integral equation of the first kind. Then Volta integral equation. Volta integral equation is nothing but, so the integration between a to b, a is a constant one and b is a variable. Then the equation is called the Volta integral equation. A linear integral equation of the form f of x plus lambda into integral a to x k of x comma t into y of d dt equal to 0 is known as a Volta integral equation. So what is the difference between Volta integral equation and Fedorov integral equation? So Fedorov integral equation contains the integration, so both a and b are constant. So Fedram integral, ultra integral equation, nothing but A is a constant one and B is a variable one. So this is the difference between ultra integral equation and Fedram integral equation. Then the second kind, so second kind is nothing but f of x, alpha of x equal to 1, a linear integral equation of the form alpha of x equal to 1, then y of x equal to capital F of x plus lambda into integral a to x k of x comma t into y of d dt is known as the ultra integral equation. Here f of x equal to 0, then the equation is called the homogeneous ultra integral equation of the second kind. Then homogeneous. So homogeneous is a linear integral equation of the form alpha of x equal to, in equation 1, alpha of x equal to 0 and f of x equal to 0 in equation 1. The limit from y of x equal to lambda into integral a to x k of x comma t into y of d dt is known as a homogeneous ultra integral equation. What is the difference between homogeneous Fedram integral equation and homogeneous ultra integral equation? Homogeneous Fedram integral equation contains, so a to b, a and b are constant. So here integral a to x, x is the variable. So a is a constant one and x is the variable, is known as a homogeneous ultra integral equation of the second kind. Why he had called second kind? So here alpha of x equal to 0. So suppose alpha of x equal to 0, then the equation is called the homogeneous ultra integral equation of the first kind. Then example, so x cube equal to integral 0 to x minus t the whole square into y of d dt, and the initial condition is y of x equal to some 3. Here k of x comma t equal to x minus t the whole square and y of t is unknown and dt. So we have to find the solution. So x cube equal to integral 0 to x minus t the whole square into y of d dt. So we have to check whether the given equation is ultra integral equation with the first kind. Then so we have to taking the right hand side. So integral 0 to x 3 into x minus t the that is nothing but, sorry, so 0 to x minus t the whole squared into dt, we have to integrate on both sides. So 3 into x minus t the whole cube whole divided by 3, so equal to, so putting the upper limit and lower limit, so substitute upper limit, so x minus t the whole cube, replace t by x 0. So putting lower limit, so 3 and 3 will be cancelled. So put t equal to 0. So take minus of minus x cube. So x cube is the left hand side. So we have to taking right hand side. We have to prove the LHS. So u of x equal to 3 is a solution of the given differential equation, because we have given y of x equal to 3. So here yt equal to 3. So we have to taking y of t equal to 3. So y of t is a unknown value. So we have to taking y given is y of x equal to 3. So we have to taking y of t equal to 3. So 3 into x minus t the whole square. We have to integrating. So 3 into x minus t the whole cube divided by 3, 0, limit from 0 to x, substitute upper limit, the values will be 0. So putting lower limit, so minus sign will be coming, minus of, so t equal to 0, so x cube. So left hand side. So y of x equal to 3 is a solution of the integral equation. Then example 2. So here u of x plus integral 0 to 1 x into e power xt minus 1 into y of d dt equal to e power x minus x and y of x equal to 1. So you have to take the left hand side. So given equation is Fedram non-homogeneous integral equation of second kind, because u of x is, so f of x is nothing but u of x, so non-homogeneous, and y of x, alpha of x equal to 1, So second kind, so limit from 0 to 1. So a and b are constant. So the given equation is Pedram integral equation. Then we have to take in left hand side. So left hand side is u of x equal to integral 0 to 1 x into e power xt minus 1. So that is nothing but y of x. So here y of x equal to 1. So 1 plus integral 0 to 1 y plus integral 0 to 1 e power x minus t minus 1 into dt equal to 1. Then 1 plus of, so the x is independent, so take outside the integral. So x into integral 0 to 1 e power xt minus 1 equal to 1 plus x into e power xt divided by x minus t, limit from 0 to 1. Then 1 plus x into e power xt differentiating with integrating with respect to e power xt, that is nothing but e power xt whole divided by x minus of t, limit from 0 to 1. Substituting upper limit, so 1 plus x into e power x divided by x minus 1. Then substituting lower limit, so that is nothing but e power 0. So e power 0 is 1. So 1 by x. So minus 0. So that is nothing but e power x by x minus 1. So minus 1 by x. Then we have to multiply x inside. So 1 plus e power x minus 1. Then plus 1 and minus 1 will be cancelled. So e power x equal to minus x, that is the right hand side. So y of x equal to 1 is a solution of the given integral equation. Then, so another type, so integral a to x and a to x1 and a to x2, that is nothing but a to x1 and a to x2, f of x1 into dx1 into dx2 equal to 1 divided by 1 factorial into a to x minus t into f of t. So that is nothing but we have to take the double integral, then we have to convert into 1 divided by 1 factorial into a to x, and this integral is nothing but x minus t into f of t. This integral will be converted into x minus t into f of t dt. Then another formula, then triple integral. So we have to convert into 1 by 2 factorial into x minus 2 the whole square into f of t dt. We have to take the triple integral, then we have to convert the formula for 1 divided by 2 factorial into a to x minus t the whole square into f of t dt. Then another formula in the nth term, so integral a to x and a to etc. in terms of n terms. So f of x1 into dx1 up to dxn equal to, so 3 terms we have to get 1 by 2 factorial. So here n terms, so we get 1 by n minus 1 factorial into integral a to x minus t whole power n minus 1 into f of t dt. So the nth formula is integral a to x and so on, f of x1 into dx1 up to dxn equal to 1 by n minus 1 factorial into a to x minus t whole power n minus 1 into f of t dt. Then the result example, so convert the following initial value problem into Volta integral equation y double dash minus y equal to 0. The initial condition is y of 0 equal to 1. This question is asked from GATE exam. Then the solution is, first we have to given for differential equation y dash minus y equal to 0 and y of 0 equal to 1. So then integrating on both sides, so that is nothing but dy by dx minus y equal to 0. So integrating with respect to x, limit from 0 to x. So integral 0 to x. So that is nothing but, so dy by dx is, we have to integrating, the value is y of x, limit from 0 to x. So minus integrating this one 0 to x y of the dt equal to 0. So substituting upper limit and lower limit. So substitute upper limit y of x, substitute lower limit y of x minus y of 0 minus integral 0 to x y of the dt equal to 0. Here y of 0 equal to 1 is given. Here y of 0 equal to 1 is given. So y of x minus 1 minus of integral 0 to x y of the dt equal to 0. So y of 0 is replaced by 1. So y of x minus 1 minus integral 0 to x y of the dt equal to 0. So taking this term in right hand side, so y of x equal to 1 plus integral 0 to x y of t into dt. So we have to convert into the differential equation into ultra integral equation, because the limit from 0 to x, 0 is a constant, x is a variable. So the equation is of the form ultra integral equation for second kind non-homogeneous, because f of x equal to 1, here k of x comma t equal to 1 and y of d dt. So y of t is a unknown one. So the solution is ultra integral equation for second kind and also non-homogeneous. Then another example, convert the following initial value problem into ultra integral equation. So given equation is y double dash x minus 3 into y dash x plus 2 into y of x equal to 4 into sin x. The initial condition is y of 0 equal to 1 and y dash of 0 equal to minus 2. So the given equation is second order non-homogeneous linear ordinary differential equation. So given is y. So given equation we have to integrating with respect to 0 to x. So second order equation we have to integrating with respect to x. So y dash of x, so limit from 0 to x minus 3 into y of x limit from 0 to x plus twice into integral 0 to x y of the dt equal to 4 is a constant one, 4 into integral 0 to x sin t into dt. So then y dash of x, so substituting limits y dash of x minus y dash of 0 minus 3 into upper limit substitute y of x minus lower limit y of 0 plus twice into integral 0 to x y of the dt equal to, so integrating sin t is nothing but minus cos t limit from 0 to x. Then so the value is given y of 0 equal to 1 and y dash of 0 equal to minus 2. So substitute these values here. So y dash of 0 equal to minus 2 is minus into minus plus. So then y of x, y of 0 equal to 1, then substitute minus 1 plus twice into integral 0 to x y of d dt equal to 4 into substitute upper limit minus cos x, substitute lower limit minus of minus cos 0. So that is nothing but plus 1. So y dash of x plus 2 minus of 3 into y of x minus 1 plus twice into integral 0 to x y of the dt equal to 4 into minus cos x plus 1. Then integrating on both sides, limit from 0 to x, then we have to integrating the particular value y dash of x is nothing but y of x, then 2 into x. So y of x limit from 0 to x minus 3 into integral 0 to x y of x1 into dx1 plus twice into integral 0 to x again 0 to x y of x1 into dx1 dx2 equal to integral 0 to x minus of 4 cos t minus 1 into dt. Then substitute this value y of x minus y of 0 minus 3 into 0 to x y of the dt plus twice into, so double integral we have to use the for above results. So integral 0 to x minus t into y of the dt. So integrating this one, so minus 4 into sin t minus t, so limit from 0 to x. And also substituting y of 0 value, y of 0 is nothing but 1. So y of x minus 1 minus 3 into integral 0 to x y of d dt plus twice into integral 0 to x minus t into y of d dt. So substituting upper limit minus 4 sin x minus x, substituting lower limit, so always 0. Then we have to taking this value from left side to right side. So y of x equal to 1 minus x minus 4, this value. So that is a minus 1. So taking right hand side 1 minus x minus 4 sin x. So taking this value for common from these two, 0 to x, y of the dt is common. So we have to take 0 to x. So the remaining value is 3 minus 2x plus 2t into y of the dt. This is the needed for the differential ultra integral equation. Here f of x is nothing but 1 minus x minus 4 sin x. So limit from 0 to x. So x is a variable one. Then k of x comma t is 3 minus 2x plus 2t. So y of dt into dt. So this is the ultra integral equation for second kind, because alpha of x equal to 1, and also non-homogeneous because f of x is not equal to 0. So f of x is nothing but 1 minus x minus 4 into sin x. Then we have to discuss some more problems. For the homogeneous Fedorov integral equation, pi of x equal to lambda into integral 0 to 1 e power x plus t into pi of d dt. A non-trivial solution exists when lambda has the value. So options are a equal to 2 divided by e minus 1, b equal to 1 divided by e squared plus 1, c is nothing but 1 divided by e plus 1, and d is nothing but 2 divided by e squared minus 1. So here, so given equation is pi of x equal to lambda into integral 0 to 1 e power x plus t into pi of d dt. So we have to uh, separate into variable separable method. So e power x into e power t pi of d dt. So e power x is a constant, we have to take outside the integration. So pi of x equal to lambda into e power x integral 0 to 1 e power t into pi of d. So that is nothing but we have to replace the value of c. So c is nothing but 0 to 1 e power t into pi of d dt. Why we have to taking replacing c? Because pi of t is the unknown function. So we have to replace. So pi of t. So pi of t is nothing but pi of t equal to lambda c into e power t. So c equal to integral 0 to 1 e power t into pi of t dt. Then c equal to integral 0 to 1 e power t into pi of t is nothing but put t x equal to t. So pi of t equal to lambda c into e power t. So substitute this value lambda c into e power d dt. So we have to multiply e power t, then so c into lambda c e power 2t, integrating e power 2t divided by 2, limit from 0 to 1. So c equal to lambda c by 2 into e square minus 1. So taking left hand side, so c, that is nothing but c into c minus of lambda c by 2 into that is e square minus 1 equal to 0. So this is wrong. E square minus 1 equal to 0. Then c is not equal to 0. So the remaining is 1 minus lambda by 2 into e square minus 1 equal to 0. That is nothing but, so we have to need for lambda. Then lambda, that is you have to cross multiply. So 2 minus of lambda into e square minus 1 equal to 2. So lambda into e square minus 1 equal to 2. That is nothing but lambda equal to 2 divided by e squared minus 1. So lambda is, so 2 divided by e squared minus 1. So option D is a correct option, because so that is a, so 2 divided by e squared minus 1 is a correct option. So option D is a correct one. Then another question. For the linear integral equation pi of x equal to x plus integral 0 to 1 by 2 pi of d dt, the resolvent kernel of r of x comma t lambda is, the given one is, so here f of x equal to x, so lambda is nothing but 1, and k of x comma t equal to 1. So we have need for resolvent kernel. Then the value is 1 by 2, 2 options are 3 by 2, 4. So here we have to compare the integral equation that is the Fedram integral equation, because 0 and 1 by 2 are constant. So the given integral equation is Fedram integral equation. So f of x equal to x and k of x comma t equal to 1 and also lambda equal to 1. So these are all needed. So k of x comma t equal to 1, lambda equal to 1. Then we have to what is the meaning that k2 of x comma t is nothing but k1 of x comma z into k of z comma t. So taking k of x comma t equal to k1 of x comma t. Then k2 of x comma t equal to integral 0 to 1 by 2 k of x comma z into k1 of z comma t. So we have to replace z. Then so k of x comma z is nothing but 1, and also k1 of z comma t is also 1. So 1 into dz equal to integral 0 to 1 by 2 into dz. So dz is nothing but z. So substituting upper limit and lower limit, so we have to get 1 by 2. So k2 of x comma t is nothing but 1 by 2. Then we have to find the k3. Then k3 of x comma t equal to integral 0 to 1 by 2 k of x comma z into k2 of z comma t into dz. Here k of x comma z is 1 and k2 of z comma t is 1 by 2. So then 1 by 2 into dz. Then integrating 1 by 2 is a constant one, taking outside the integral. Then integrating dz is 1 by 2. So substituting upper limit and lower limit 1 by 2. Already we have 1 by 2 here. Then 1 by 2 into 1 by 2 is 1 by 2 square. So this way process is and so on. So we have to get an kn of, then k4 of x comma d is nothing but 1 divided by 2 power 4 and so on. We have to get kn of x comma t is nothing but 1 divided by 2 power n minus 1. So kn of x comma t is nothing but 1 divided by 2 power n. The resolvent kernel is, so r of x comma t comma lambda equal to summation of n equal to 1 to infinity lambda power n minus 1 into kn of x comma t. Then substitute these values. So here lambda is 1 and kn of x comma t is nothing but 1 divided by 2 power n minus 1. So this is a geometric progression, 1 plus 1 by 2 plus 1 by 2 square and so on. So 1 by 2 is less than 1. So 1 divided by 1 minus r. So that is nothing but a divided by a minus r. So 1 divided by 1 minus 1 by 2. So cross multiply 2 minus 1. So that is nothing but 1 divided by 1 by 2 is nothing but 2. So option B is a correct option. That is option is, so B is a correct one. So this question is option B is a correct one. Then another question. So this question is pi is a solution of the integral pi of x equal to 1 minus 2x into minus 4x squared plus 0 to x plus 3 in plus 6 into x minus t minus 4 into x minus t the whole square into pi of d dt. Then what is the value for pi of 1? So we have to use the formula for Laplace transformation, because the values are x minus t into x minus t. So we have to using the convolution theorem. So we have to apply the Laplace transform on both sides. So taking Laplace transform on both sides. So here L of pi of x equal to, so L of whole term plus L of the whole integrand and L of pi of t. So that is nothing but, so using convolution theorem, L of pi of x into L of this value into taking L of 3 plus 6x minus 4x squared into L of pi. Then so taking these values in left hand side, then L of pi equal to 1 by s minus 2 by s squared plus 8 by s. That is nothing but L of 1 is 1, L of x is nothing but 1 by s, L of x squared is nothing but 2 divided by s cube. So here these values. So taking these values in left side, so taking common for L of pi, then 1 minus of these values. into L of by equal to S squared. So taking LCM, so S cube into S squared minus 2S into minus 8. Then taking LCM, S cube minus 3S squared minus 6x plus 8 divided by S cube, and S cube cancelled. So we have to factorize in the term. So S squared minus 2S, we have to divide and factorize. So S squared minus 2S minus 8. So these values get cancelled. So remaining is L of pi equal to 1 divided by S minus 1. So so pi of S equal to L inverse of 1 divided by S minus 1. So that is nothing but pi of x equal to e power x. Then pi of 1 equal to e is a correct option. Then option B is a correct one. So thank you.